Hey guys, hello everyone and welcome to the channel. So this is the fourth part of inorganic NMR spectroscopy. In the previous part of inorganic NMR spectroscopy, we have understood that how the peaks are emerged, how the splitting takes place, how J coupling takes place, and how J coupling merge with each other, what is Pascal splitting, what is non-Pascal splitting. We have done all of these in the previous previous three parts of the videos. So today I am going to talk about spin dilution effect, or the effect where satellite peaks comes. Okay, so I am going to talk about satellite peaks and the spin dilution effect. So this is super important video, because if you are studying inorganic NMR spectroscopy, this is something which you should understand. Okay, and questions from here has been asked in the previous CSI NET exam. I will discuss them at the end of this video. I will solve them and I will show you how to solve those types of questions. First, we will try to understand that what exactly this spin dilution is. It's a very simple concept, but still many people don't understand it properly, and that's why they do mistake in questions, right? So we'll try to understand it from basics. We'll try to understand it, that what exactly it means, how it is emerged, why exactly it is like that, why it is called satellite peak. So everything I'm going to talk about in detail in this particular video. So do watch this till end. Also, if you are new to this channel and if you are watching the videos, if you like the content, please do consider subscribing it. And now, without wasting any time, let's continue with our video. I'm going to talk about spin dilution effect. Okay, so what exactly spin dilution is? So see, if there are metal in the complex, okay, if there are metals or there is some central atom or central atom in the molecule, and if there are more than one isotope of that metal, more than one isotope of that particular atom, and those isotopes, among those isotopes, some are NMR active, some are NMR inactive, in that case there will be variation in the height of the peaks. Okay, and that height of the peak, that variation in the height of the peak results in formation of satellite peaks. Okay, so that's what exactly it is, that's what the definition of this actually talks about. But let me first of all tell you that what exactly we are going to look upon, the terms which we are going to actually look upon. So the first term which we will talk about is intensity of the peak. Okay, so intensity of peak. Now understand that when we are talking about intensity of peak, especially when we are talking about intensity of peak in NMR spectroscopy, then in that case we are referring to two things. Okay, the first thing is the number of species in the molecule, right? And the second thing which we are referring to is the abundance of them. Okay, abundance of the species. So number of species you might have seen in the organic NMR spectroscopy, where you might know that if there is a peak which is emerging because of methyl group and there is a peak which is emerging because of CH2 group, so the intensity or the height of this peak is basically going to be more as compared to the height of this peak, right? So that's because this is caused because of 3 hydrogen and this is caused because of 2 hydrogen. So the number of species is different in both these peaks, the peaks are emerging because of different number of species, and that's why their height is corresponding to the number of species which are responsible for that particular peak. So intensity of the peak can also be understood as the height of the peak. All right, so that's how you can understand. Now second thing comes over here is abundance of the species. Now this thing generally does not comes in organic spectroscopy, but this thing comes in the inorganic spectroscopy. So I'll tell you, first of all I'll explain you this on the basis of mass spectrometry. So in mass spectrometry, if you know, there are two peaks like M and M plus 2 peak in case of, let's say, chlorine, right? So if we have two chlorine molecule, one is chlorine 35 and the other one is chlorine 37, the abundance of chlorine 35 is somewhere around 76% and the abundance of chlorine 37 is somewhere around 24%. The ratio of both of them is somewhere around 3:1. So that's why the intensity of these two peaks, M and M plus 2 peak, is basically 3:1. So this intensity came because of the difference in the abundance of these species, and that's what we are going to observe in the inorganic NMR spectroscopy as well. So if there will be two species having different amount of, or there will be different value of abundances, in that case the height of the peak corresponding to that particular species will also be different. Okay, so did we understood? So this part we are not going to look upon, like this number of species we are not going to see in the inorganic NMR spectroscopy. The majority of portion which we will discuss today, that means in the concept of satellite peak, will be about abundance of the species. So higher the abundance, more will be the height of peak, lesser the abundance, smaller will be the height of peak. All right, now let me talk about that what exactly a satellite peak means. Okay, so satellite peak, basically the word comes, like the first word is satellite, so it has to do something with satellite. All right, so that means if it has to do something with the satellite, so there should be some properties of the satellite which this peak is actually following. So what does a satellite is? So first thing is, what does satellite do? A satellite hovers around the major or the heavenly body. Let's say if I talk about Earth, so there are two types of satellites, artificial satellites and natural satellites. So the natural satellite of Earth is Moon. So what does Moon does? Moon just hovers around the Earth. It rotates around the Earth. So that means it is found near to Earth, or wherever Earth will go, this satellite of the Earth will also be present around it. So satellite peak, what does it mean? Satellite peak is going to be found around the major peak, all right, or also called as main peak. Okay, so what does that means? It means that the satellite peak is going to be found around the main peak. Okay, so that's the first property of satellite which it is following. Second thing is that the height of this peak, height of satellite peak is smaller than main peak. So just like the satellite of Earth, which is Moon, is smaller than the main heavenly body, means the Earth, so in the same way the height of the satellite peak will be smaller than the main peak. So as I said, height of the peak, so I have already explained you about the abundance. So this will do, like there will be something related to the abundance of it. Okay, so now since we have understood what is satellite peak or what are the properties, okay, you can understand it as properties of satellite peaks. Okay, so it will be found around the major peak and the height of the satellite peak will be smaller than the main peak. We have also understood about the intensity of the peak. So let me explain you spin dilution effect in detail now. Right, so the spin dilution is the concept which comes when let's say if you have a metal, okay, it can be metal or it can also be a central atom. Okay, it can also be a central atom in any inorganic molecule. So if there is any metal or a central atom which has more than one isotope, among which one of them is NMR active whereas the other ones are NMR inactive. Okay, in that case spin dilution takes place. Spin dilution means the spin is going to get diluted and because of that the intensity of the peak changes. Okay, so as a result of this spin dilution, so as a result satellite peaks are observed. Okay, so what does satellite peaks are? So satellite peaks can be said or they can be understood as the result of a spin dilution effect. Now let's take an example and try to understand that how it happens. So let's say we have platinum. Platinum is having two isotopes. One is 195 which is NMR active. Okay, so this one is NMR active and it has I value of 1/2. All right, so this is one of the platinum isotope and the other isotopes are like other isotopes of platinum which are 194 platinum, then you have 198 platinum, so many other isotopes are there. They all are NMR inactive. Okay, so if they are NMR inactive, that means I value for them is 0. So that's what you have to understand. So let's say if this is the condition that we have two isotopes, one is 195, one is 194. 195 is having I value half, 194 is having I like all the other isotopes have I value 0. In that case, what will happen? See, let's say if we have platinum attached to hydrogen, that's all. Okay, let's say we have just metal attached to hydrogen. I'm not taking the whole complex, I'm just taking a bond to explain you. And you are looking upon proton NMR and you are trying to observe the proton NMR. Now see, this platinum over here is not mentioned or it's not specified that which platinum it is. So that means ki here you are going to have both the types of, like all the types of platinum will be here. It will have platinum 194, 195, 198, all the isotopes of platinum will be present over here depending upon their abundances. So let's say that platinum 195 has 34% abundance, let's say. So it means ki platinum 195 has 34% abundance, rest others is 66%, and those are NMR inactive. So what information we have till now? We know ki platinum has 195 isotope which is 34% abundant and it has I value of half, whereas all other isotope overall make 66% of the abundance and they have I value 0. So what will happen over here now? See, this hydrogen or this proton, when you are going to observe in the NMR spectrum of this, so this hydrogen is going to split it, like it's going to have a splitting in its peak, and who is going to split that? Of course this platinum is going to split that. Now which isotope is going to split it? So 195 will also split and the other isotopes will also split it. So how does 195 platinum is going to split it up? So the splitting which takes place because of platinum 195 will be done with the same formula 2Ni plus 1 which we have done in the previous videos. So 2N value will be 1 because there is just one platinum, I value is half and plus 1. If you solve it, you are going to get 2, that means you are going to get a doublet. So 195 platinum is going to give you a doublet, whereas all the other isotopes combinedly they are going to give you 2Ni plus 1. If you use this formula, so 2 into 1 into 0 plus 1, this is going to give you 1, that means a singlet. So 66% of platinum is going to give you a singlet and 34% of platinum is going to give you a doublet, right? So a single peak of hydrogen which was coming in is going to split up into two peaks because of platinum 195, and the same peak is also not splitting up and giving you a singlet peak because of all the other isotopes. So how does your spectrum is going to look like? Of course this 66% abundance one is going to have a higher intensity and you are getting a singlet, so that's why you will observe a singlet like this. Okay, so this will be a singlet which you are going to observe, and this will come because of this more abundant isotopes of platinum which are NMR inactive, means all the other isotopes of platinum, whereas the other platinum which is platinum 195 is also going to split it up, and this is going to give you a doublet, and that doublet will also be present at the same position but with a lesser intensity. So that is going to give you a doublet like this at the same position. Okay, now the intensity of this doublet will get divided because it is 34%, so half of this is 17, so the abundance will be 17 and 17%, whereas the central or the major peak will be 66%. So this is going to be the overall spectrum. This is how you are going to observe the overall spectrum. Now few things which I just want to explain you over here. First thing is that why both of these platinum are going to give peak at the same point or at the same position. That is because the chemical environment around this platinum is same. Okay, both the platinum are in the same chemical environment. It is just the difference of their I values and just the difference of their abundance which is causing them to show two different types of peak, but the position, like where they are going to show that peak, it depends upon the chemical environment around it, and since that is same, so that's why both of them are going to give you peak at exact same point. Okay, so that's why you are getting peak at the same point. First thing, so this is one thing which is done. Second thing is that why the height of this peak is smaller. I have already explained you, because the abundance of this is less, 34%, and that's why its height will be smaller, and since it is more abundant, that's why it is going to give you much higher or much height peak. How the splitting is happening, that is just based upon the splitting formula 2Ni plus 1, that is the formula with which you have just done it. Now what will be the name of this? So these red peaks which you are observing over here, these are basically called as satellite peaks. Okay, so these are the satellite peaks, and whose satellite peaks are they? They are satellite peak of this major peak or the main peak. So this black colored peak over here is the major peak or the main peak, and these red ones are the satellite peak. Now you must be wondering that why they have become 17%, because overall we have to make 100%, of course. So this is 66%, it is splitting into two peaks, so the intensity will get divided and 34 will get divided into 17 and 17, and that's how you are going to get. So this is the whole concept of satellite peak. What do you have to what are the conditions which are there? You should have a metal with different isotopes having different I values, and they should have difference in the abundance as well. In that case, you are going to observe satellite peak, and there will be spin dilution as well. So what is spin dilution over here? Spin dilution has happened, that's why the intensity of these peaks has decreased and the intensity of this peak is more. So there is a difference in the spin of both of them, and that's what we have understood over here, right? So till now we have understood satellite peaks. Now we are going to take some examples from the previous years and we'll try to see that how to solve them up. Alright, so let's look upon this particular question here. It says that the expected number of 19 F NMR spectral lines including the satellites for XCF5 minus is. So first of all, you should know the structure of XCF5 minus. So XCF5 minus is going to have pentagonal bipyramidal shape. Okay. So pentagonal bipyramidal is going to look something like this. We will be having 5 fluorine attached on the same plane, and then we will be having 2 lone pair above and below the plane. Okay, so that's how the structure is going to be. What does that mean? It means we have only one type of fluorine in the molecule. All the fluorine are equivalent, and who is going to split these fluorines? So xenon is going to split that. And in the question itself, they have said that you have to include the satellites. They have also given you the data that xenon 129 is one of the isotope which has I value half and it is 26%. Let's consider that we have xenon 129 and it has I value of half, and we have abundance of 26% for them. The other isotopes we don't know, and they will be I is equals to 0 because they are not mentioned, so they must be NMR inactive, and their abundance will be 74%. Alright, so what will happen that since we are doing fluorine NMR, so fluorine, all the fluorine are equivalent, so equivalent fluorine is not going to split the other equivalent fluorine. So who is going to split them? This xenon is going to split them up. Now in how many lines this xenon is going to split? So first we will talk about the xenon which is less abundant, which is 26%. So we will use 2Ni plus 1 formula. There is just one xenon, I value is half plus 1. If you put it, you are going to get 2. So it is going to split it into 2 lines. Whereas the other xenon which is having I value, the other isotopes which have I value 0, if you put in the same formula, it will be like just 1. Now the condition is quite similar to what we have taken as a previous example. Now what will happen, that this peak, the single peak which we are getting, will be more abundant, of course. Why? Because it is 74% abundant, and that's why you are going to get that major peak. And the satellite peaks, the other 2 peaks, the splitting of that is going to be, because of the less abundant one, 26%, and that will remain over here only 30%. So they will be 13%, and this will be 74%. So this is how the overall spectrum will look like. Actually, to be very frank, let me draw a more accurate one. So the more accurate spectrum is going to look something like this. So this will be much more larger. 74% major peak, the satellite peaks of 13% each. So overall, how many peaks did you got in the molecule? We have got 3 peaks over here. So that's how a satellite peak concept comes over here, and we have already seen the previous example. It is quite similar to that. It is just one more example where you don't need to have a central metal, like you don't need to have a metal atom, a central atom with difference in the, with following the similar conditions can also work. Okay, you don't need to always have a metal over there in order to have satellite peak. You can see xenon can also work because xenon has it has 2 types of isotopes, 129 and the other isotopes which are inactive, right? Now one more question which was again asked in CSIR net exam. This was asked in 2018 exam. This says December 2018. It says that the 31p proton decoupled NMR spectrum of cis PT PET whole twice Cl2, it has 195 platinum, which is 33.8% abundant. I value is half. Its other isotopes are NMR inactive, and it is said ki I value for phosphorus is basically half. It is comprised with the satellite peak of. Again, let's try to make the molecule first of all. So we have cis PET whole thrice. So PET whole thrice. Okay, ET sorry, Et whole thrice means you should have 3 ethyl molecules. So let me make 3 ethyl molecules again, 3 ethyl molecules and chloride and chloride. Okay, so this is my complex. Now it is said that this is phosphorus proton decoupled NMR, means proton are not going to participate in splitting, they are not going to cause splitting. Whenever you see this curly bracket, that means this is decoupled NMR, means that particular species is not going to participate in the splitting part. Okay, fine. So who will split this phosphorus now? Only NMR active element in the whole molecule or in the whole complex is platinum, because both these phosphorus are equivalent. If both of them are equivalent, this platinum is going to cause splitting. In how many lines? Of course, depending upon again the same thing, the satellite peak concept is going to come, because you have two types of isotope, 195 platinum which has I value half, abundance is 33.8%. The other one, that is the other isotope will have I value 0, abundance will be just around yeah, so it will be 34, so 6 will make it yeah, so 66.2%, right? That's what is going to be the abundance of them. Fine. So this I am not going to solve again, the same formula you can put, and this is going to give you a doublet, whereas this is going to give you a singlet. Both of them are going to stay at the same point, so that is going to make the overall spectrum something like this, right? These two are small ones, are satellite peaks. This is the major peak with 66.2% of abundance. These are going to be half of that, that means these are going to be 16.9%. okay, so 16.9% of abundance. So now the question was ki it is comprised with the satellite peak of. Now here is something which they have made, like they have tried to confuse you over there, because many of the people just understood this much and they just went like they just tick the option number A. It's not going to be done like that. See, it says it comprised with the satellite peak of. Whose satellite peaks are these? These are satellite peaks, of course. Okay, so these are satellite peaks, right? These are satellite peaks. But whose satellite peaks are they? They are satellite peak of this main peak, right? These are satellite peak of this main peak. So they are basically asking about the main peak here. They are telling that the phosphorus NMR spectrum of this molecule is comprised with the satellite peak of what? Satellite peak of what? So satellite peaks are there, but whose satellite peak are there? They are satellite peak of the main peak, and the main peak is what in nature? It is singlet in nature. Okay, this was our main peak, right? This was making our main peak because of more abundance over there, so that's why that was making the main peak, whereas the other one is making doublet. These are our satellite peak. All right, so that's why we can say that the correct answer will be option number B, which is singlet. Now this was the question where many people did mistake. A lot of mistakes were made in the exam and a lot of people got negative marking this question, but now you have understood how to do this, right? So satellite peak was a easy concept. This was all about this concept in this particular video. I just thought to explain you in detail in a single video, so that you don't have to watch anything, you don't have to understand from any book, from anywhere. If you watch this video till here, you have understood the concept, you can do questions based upon satellite peak now. So that's it from my side for this particular video. Thank you so much for watching it, and I will see you guys in the next one. And do let me know in the comment section if you want some specific topic from me, so that I can make the future videos on those topics. So that's all from my side. Thank you so much for watching, and I will see you in the next one. Until then, have a great day. Bye bye, guys. So I teach live on Unacademy Plus platform. Here I teach for the CSIR UGC NET category, and you can follow me over here for regular classes. You can access my free classes as well as my paid classes on this particular platform. The classes which are free, you can get that under the section of special classes, whereas in order to access my paid classes, paid live classes, you have to take Unacademy Plus subscription. So do make sure that you take the Unacademy Plus subscription to access all my paid classes, which are quite organized. The whole syllabus is being completed over there, and the classes are quite regular over there. So make sure that you take Unacademy Plus subscription by using my referral code, that is N_Huda. That's it for this. Thank you so much.